In last two lectures, we have been dealing with motion along a straight line. Today, we take motion in a plane. What is the difference? Along a straight line, you need not distinguish between velocity and speed. In a plane, however, this is not possible. Velocity and speed are now two different physical quantities. In a plane, what we do is we take velocity in whatever direction it is and break it up into two components, one along the x axis and the other along the perpendicular y axis. The components are V x equal to V cos theta and V y is equal to V sin theta, and we study the motion along these two components independently and then later on superimpose to find out the actual motion of the body. So, as an example, we take a building which is 125 meters high. From the top of that building, we launch an object horizontally with a velocity of 10 meters per second. Now, in the horizontal direction there is no other force, therefore, the object would move 10 meters in 1 second, 20 meters in 2 seconds and so on. However, in the vertical direction there is the force of gravity, and therefore, the distance covered in the vertical direction would be given by y equal to half g t square. So, we after each second we note the position along the x axis and the position along the y axis from the top of the building, and we assemble the data in this table. Here you see horizontal axis, the distance is 10 meters, 20 meters, 30 meters after 1, 2, 3, 4, 5 seconds. On the vertical axis, the distance from the top is 0, 5, 20, 45, 80, 125 meters, and we plot this along the x and y axes, and we find that the curve has this shape. What is this shape? This shape is called a parabola. A curve of this shape is called a parabola. Let me give you a few examples of this curve, the parabola. You see, you have a water tube and the water will come out of this. Let us say the path that this water describes is a parabola. When a batsman hits a cricket ball, I mean cricket must be your favorite game. When a batsman hits a ball, then the ball that has a trajectory or a path which is parabolic. An athlete attempting a long jump launches herself into a path of this shape as shown here. If you have been to a seaside, you must have seen dolphins jumping out of water and going back into water. I will show you here. This is a dolphin coming out of water, jumps up, comes down into the water, and what is the path? The path followed by this dolphin is a parabola. So, we have now enough recognition of parabola. So, let us see how we can now describe the motion of an object which is launched at an angle to the horizontal from the ground, just like a batsman hits a ball, and then let us see what kind of path it would follow. As before, we have got the components of velocity, v cos theta along the x axis, v sin theta along the y axis, and study the motion independently, and then we superimpose one above the other. The motion along the x axis is independent of any force. So, therefore, the distance covered in time t along the x axis is v cos theta times t, no force is acting. In the y direction, there is the force of gravity, and therefore, the distance covered in the vertical direction is the vertical velocity v sin theta into t minus half g t square, where g is the acceleration due to gravity. To get the equation of the path in the x y plane, we need to eliminate t from these two equations. So, we eliminate t and we get the equation y equal to x times tan theta minus half g x squared divided by v squared cos squared theta. This equation is of the form y equal to a x plus b x square, which you recognize from geometry is the equation of a parabola. I show you here the path followed by this body which is launched at an angle to the horizontal. Such a body is called a projectile. So, this path is that of a projectile. Sometimes this path itself is known as projectile, but the projectile is the body which is launched. And you can see here I have got in red color the velocity v, then I have got components v x, v y. V x you can see stays constant, you can see the length of v x stays the same. V y velocity along the vertical direction of course decreases because of the acceleration due to gravity trying to bring it back, and at the top of the journey v y becomes 0, then it starts falling back and comes back to the earth, comes back to the ground, and you can see the velocity v again can be broken up into components v x, v y. V x is the same and v y is also the same because of conservation of energy. So, this is the path followed by a projectile, this is the path followed by a ball hit by a batsman. Vertically upward velocity is v y equal to v sin theta. The highest point reached is v sin theta square by 2 g. At the highest point the upward velocity is 0, but there is a downward acceleration equal to g. The horizontal velocity at this point is constant, as I showed you in the last slide. The time taken by the projectile to reach the highest point of this trajectory is t equal to v sin theta by g. In this time the projectile has travelled a distance horizontally, a distance t into v cos theta, and if we substitute the values we will get this distance which is called the range of the projectile. This is equal to v squared sin 2 theta by 2 g, and you can see that if theta is 45 degrees the range is the maximum. I will show you in this slide. I have drawn graphs for projectiles which are launched at an angle of 30 degrees, at an angle of 45 degrees, at an angle of 60 degrees, and you can see that the projectile at an angle of 45 degrees has the maximum range. So, here I have collected all the facts about the projectile. The horizontal velocity is v cos theta and distance covered is v cos theta into t. Horizontal velocity is v sin theta and the distance covered is v sin theta into t minus half g t square. We eliminate t from these two equations and we get y equal to tan x into tan theta into x minus half g x squared by v squared cos squared theta. This is the equation of parabola. The highest point reached by the projectile is v sin theta square by 2 g, and the range, the maximum horizontal distance covered by the projectile is v square sin 2 theta by 2 g. Let us take one or two examples to fix the ideas about this projectile. Let us take this example. You see, this is a very familiar example. A helicopter on a rescue mission, when there are floods, the government orders helicopters to drop food packets on people who are marooned. So, here we have an example of a boat which is marooned in a river or somewhere, and we have a helicopter which is going to drop the food packets on the boat. So, a helicopter on a rescue mission spots a boat at a horizontal distance of 40 meters. The helicopter finds that there is a boat at a distance of 40 meters from it. If the helicopter is at a height of 20 meters and is moving with a horizontal speed of 10 meters per second, at what horizontal distance from the boat should it release the food packet so that it hits the boat? You see, the food packet, as you recall, would have the horizontal velocity of the helicopter. So, the food packet starts with a velocity of 10 meters per second. So, remember this, and we are going to take g equal to 10 meters per second square for the simplicity of calculations. So, let us solve this problem for the helicopter pilot, so that he does not make a mistake. First, we must find the time taken for the food packet to fall the vertical distance of 20 meters. This is given by h equal to half g t square. So, plugging the numbers we get t equal to 2 seconds. So, it will take the food packet to travel a distance of 20 meters along the vertical direction would be 2 seconds. We want that the helicopter should release this packet such that in 2 seconds it covers a horizontal distance also of 20 meters. So, that it falls in the boat itself. Let me remind you, show you once again the problem. Here is a helicopter. Helicopter must release the packet here, so that it travels along a parabola and then falls on the boat. It does not miss the boat, does not fall before the boat or after the boat. So, it will take 2 seconds, and in 2 seconds the packet needs to travel a distance of 20 meters. So, if the helicopter releases here, what will happen? The packet would fall here. If the helicopter releases here, then the superposition of the vertical motion and the horizontal motion would be such that the packet falls in the boat itself. This is very important for the pilot of the helicopter to know. Let us take another example. All of you are familiar with Virat Kohli. I know most of the students have Virat Kohli as one of their icons. He hits a ball at an angle of 45 degrees to the horizontal. Not that he always does that, but as an example we can take the 45 degrees to the horizontal. The ball lands at a distance of 80 meters from his position, that is, from the pitch the ball lands at a distance of 80 meters. Assuming g equal to 10 meters per second square, find the time for which the ball was in air and how high it went. You see, that is also important for the fielder, because the fielder must know where the ball is likely to fall, so that if he is there, he to catch the ball. So, let us plug in the numbers again, and we know that the range is equal to v squared sin 2 theta by 2 g, and everything is given, angle is given, g is given. So, we can find the range is given. So, we can find out v, and it turns out that v is 40 by root 2 meters per second. That is the velocity with which the ball is launched. With this velocity, the time taken by the ball to reach the highest point of its journey is u by g, and that time is 4 by root 2 seconds. 4 by root 2 seconds to come down also. So, the total time would be twice into 4 by root 2. Then we get the ball in the air, therefore, stays for 4 times root 2, and the vertical distance travelled again you can find from half g t square, and that is equal to 40 meters. Let us take another example. This one is from the police. You see, a bullet is fired towards an object which is at the same height as the gun. If the distance of the object is 100 meters and the speed of the bullet is 100 meters per second, at what angle to the horizontal should the gun be pointed, so that the bullet hits the target? We take g once again as 10 meters per second square. You see, if the gun is kept horizontal and the shot is fired, because of the acceleration due to gravity, it will never hit the target. Similarly, if you make the angle larger, again the bullet will go up and may not hit the object. So, this angle has to be very carefully calculated by the person who is going to shoot the bullet from the gun, and therefore, we have taken this problem. You see, this can also happen. Suppose the army is launching a missile on an enemy to destroy the enemy guns or enemy airports or whatever. If the army does not do it correctly, what will happen? Instead of hitting the target that the army wanted, the missile would hit innocent people, either before the target or after the target. So, this targeting is very essential, and you need the knowledge of parabola, you need the knowledge of a projectile motion, and this angle theta therefore is very critical. So, let us see how we calculate this angle. It is obvious that if the bullet is fired horizontally like this, because of the attraction of the earth, it will take this path, and therefore, if the target is here, it will not hit it. So, we must point it at an angle, as I explained to you earlier, at an angle, so that the path taken like this hits the target. So, it will hit a point lower than the object if it is fired horizontally. If the bullet is fired at an elevation of theta to the horizontal, the vertical component of its velocity would be V y equal to 100 sin theta meters per second, and the horizontal component will be V x equal to 100 cos theta meters per second. Now, we know how far the target is. So, we know the range with this velocity, we find the range and then we will fit in with the equation to find theta. So, let us go step by step. Now, the time taken by the bullet to reach its highest point is V y by g. It takes the same time to come down. So, the time taken is 2 t, which is 2 y V y by g, and in that time the distance covered horizontally would be 2 t times V x, which is the range we have found earlier, and therefore, we get the equation 2 into 100 sin theta into 100 cos theta divided by 10, which is g equal to 100. From this we find what the angle theta would be. We find that theta would be in this case 2.85 degrees. But as I have been explaining, it is very important that we have the correct calculation of the angle, otherwise we will not hit the target. And as I said earlier, it is very important for the army to launch their missiles such that they hit the place which they want to and not kill the innocent people. In the next lecture, we shall continue with the motion in a plane and study circular motion. Circular motion is another important concept, and we shall find that when a body moves in a circular orbit, it experiences a force pulling it towards the center of the orbit.